Okay, so we've got two stars which are attracted to each other by gravitational attraction, and I've given the mass m1 and m2 for the two stars, and the force of gravity is the same on each star in that it's the same magnitude, but they act in different directions, opposite directions. They're also orbiting a common point, so this cross is the centre of mass, and both stars orbit in a circular path around that centre of mass. So first of all, we're going to look at the gravitational attraction between the two stars, and I've labelled that Fg is equal to G m1 m2, so it's familiar Newton's law of gravitation. Big G we know the value of, that's constant. M1 is the mass of this star, M2 is the other star, and R1 is the separation of the two stars. Now, because each star is orbiting the other, they move in circular paths, and we're going to look at just M1. They will in fact both take the same time to do one full orbit, but M1 describes a much smaller circular path than M2. We'll just look at that one first. So if we were to look at the centripetal force on M1, it must be the same as the gravitational attraction that is acting on it, and therefore we can write out the centripetal force, which we know would be mr omega squared, in this case m1 r2 this time, because it's a smaller radius now. It's not the full distance between the stars, it's just the radius here. And omega squared is the angular velocity squared. So what we're going to do is equate these two terms together, because we know they must be the same. So down the bottom here, we've got Fg is equal to Fc. Gravitational force is the same as the centripetal force. If we write the two equations like this, we can see that m1 cancels, and then rearranging that for omega, we get omega equals the square root of gm2 over r1 squared times r2. We can evaluate that just by substituting in, and then the final question is, how long does the period last? How long is the period of rotation? So we know that capital T, the period, is 2 pi over omega. So once we've got omega here, simply calculate T by 2 pi over omega. That gives us the time in seconds, but we want to convert that into years. So we divide capital T by the number of seconds in 1 year, and that gives us a number of years. And it turns out to be approximately 108, which is rounded to the nearest 100, gives us 100 years here.